Hello, everybody, and welcome to Story Time with Mr. Thompson, where every story involves math before you ask, because I know that's something that you're going to ask. Yes, this story involves math. Today we are going to be talking about the circumference of Earth, and we're going to be talking about how this famous mathematician and scientist and poet, he was a man of many talents, Eratosthenes, figured out how to find the circumference of the Earth. Now, before moving on, I want to show you how Eratosthenes spells his name. This is what it looks like. Eratosthenes. Eratosthenes. Now, Eratosthenes lived in the year when he figured this out was 240 BC. So a little over 2,000 years ago was when he figured this out. Now, Eratosthenes lived in Egypt in a city, modern day Alexandria. Now, Alexandria was north of Syene, and it was north by about 800 kilometers. Now, this was something that he knew at the time, that it was about 800 kilometers away. Even though they used a different sort of measurement, modern day we know that it was what he knew was equal to about 800 kilometers. Well, keep in mind back at this time it was much more difficult to travel, but he knew that in this city to the south of him, Syene, that there was a well, and these blue lines right here represent the well. And on one day every year, which was the summer solstice, he knew that you could see the sun directly up in the sky. And when the sun was directly in the sky, it shone directly into that well with no shadow on the bottom of the well. Well, he knew that this was so because the city of Syene sits on the Tropic of Cancer, which means every year on the summer solstice, that sun is going to be directly up in the sky. Now, it kind of looked like this. The picture to the right shows you what it looked like on the summer solstice. The picture to the left would show you what it would look like on a different day. There would be a small shadow in the corner of that well. Well, he knew that this was a special day, but he knew that the same thing did not happen in the city of Alexandria. Remember, he was just north, 800 kilometers north. So in the city of Alexandria, and this is represented by this blue line here, he knew that there was a tall statue. And on that one day, the summer solstice, he knew that in the city of Syene, that there would be no shadow in the bottom of that well. But in the city of Alexandria, he noticed that this tall statue did have a shadow. Now, two things he knew here. First off, he knew that the sun's rays, and you can see by these yellow lines here, the sun's rays were parallel to one another. That means they're all coming in sloped the same way from the sun to the earth. So he knew that the rays in Syene and in Alexandria were hitting in the same way. But because there was no shadow in Syene, but there was one in Alexandria, he also knew that the earth must be round, which was something that was pretty cool back at this time because this was something that was still being debated. Now, from this, Eratosthenes figured something out. He figured out that since that tower in Alexandria had a shadow, one thing he figured out was he said, what if I measure the angle that this shadow is coming off? So basically, he measured the angle of the shadow and figured out that that angle of the shadow must be the same angle that is between the cities of Alexandria and Syene. And he figured out that this angle was 7.2 degrees. 7.2 degrees. Now, he knew a couple things here. He knew that a circle, you guys know this too, a complete circle going all the way around is 360 degrees. Now, from this, Eratosthenes kind of calculated, basically what he did was he did 360 divided by 7.2, and he figured out that the distance between Alexandria and Syene must be 1/50th of the entire circumference of the Earth. Now, if he knew that the distance between Alexandria and Syene was 800 kilometers, the question is, how did he calculate the circumference of the Earth? So I want to go back and say that one more time. He knew that that angle that represented the distance between Alexandria and Syene was 1/50th of the circumference of the Earth, and he knew that that distance was 800 kilometers. Think about how he used this to calculate the circumference of the Earth. What I would like you to do is I would like you to calculate the circumference of the Earth by using Eratosthenes' method. Give that a shot.